So yeah, welcome everyone. Thanks for the time. Thanks for joining us today. Thomas and I here will be going through just some of the latest regulatory aspects of E911 and what's going on in the marketplace today. This is a pretty hot topic. We've got a lot of activity in the space right now. So we're going to dig in and go through a lot of different aspects of today, covering several different aspects of E911 and what's going on with these latest regulations. Thomas, you want to kind of tell everybody a little bit about where we're coming from?
Sure. So both Robin and I have been in the 911 industry for quite some time in a lot of different roles, working with wireless carriers, working with public safety. Bandwidth, for folks who might not know us, is I always love to say it's the largest voice over IP network provider that you've never heard of, because we're a wholesaler, but a lot of the brands that you see on the screen right now are companies that we are the backbone network provider for. So on the left-hand side of the screen, you can see that Bandwidth as a whole, just a little bit about the company, provides voice, telephony services, telephone numbers, long distance, international calling, all that kind of good stuff. We've got messaging. So on any number that you get from Bandwidth, you can do text messaging or multimedia messaging. Of course, we have our 911 portfolio and a broad portfolio of API technologies that allow non-telephony use of telephony resources. And on the right-hand side of the screen are some exemplary customers that use Bandwidth products.
Yeah, very good. Yeah, I like. I agree with you, Thomas. That's a good way to put it. Is we're one of the largest networks out there that you may not have not heard of, but probably use every day. We've got a lot going on behind the scenes, and we power a lot of these services, and especially from a 911 perspective. Now, one thing we do want to highlight now is that Bandwidth's on a global scale. Yeah, go ahead.
Right. Yeah. So just to complete the picture, only 2 slides on Bandwidth. We recently, within the last year and a half, acquired a company called Voxbone. So many of the folks who actually do know us as the largest VoIP provider that nobody has heard of, but that has heard of us, think of us as a U.S. North American centric organization. But we actually now cover, through our acquisitions, over 60 countries, covering 93% of the gross national product of the globe. So we are expanding. The services we're going to talk about today, Raybaum's Act and Kerry's Law specific, are indigenous to the United States. So for those who might be looking at us internationally on this call, we're really going to focus on the North American regulatory side. But as a company, we're growing and hope to grow with you. Robin?
Yeah, perfect. So let's take a few minutes to just review and cover the foundation and just the layers of the regulations that are out there today and what's going on. And I like to refer to this as the regulatory landscape, right? And just to cover the baseline of what's going on here and what's relevant, right? So several years ago, there were 2 main pieces of legislation, Kerry's Law and then Raybaum's Act. And they kind of have come together to direct the FCC to create these regulations that apply to what's called MLTS, or multi-line telephone system operators, right? And so I get that question a lot, Robin. Is Bandwidth compliant with Kerry's Law and Raybaum's Act? And my answer is always, well, technically no. Technically, we enable our customers to comply with these emerging regulations. And so from a timeline perspective, these are all in play right now, right? And that's a big part of what Bandwidth does, is we help our customers comply with these regulations that are now in play. The last deadline came in January earlier this year, January 6th of 2022, was when the non-fixed endpoint regulation came into play and is required. So we live in a world today where these regulations apply, and they are applicable to anybody who operates a MLTS system today. So yeah, any more color you want to add to that, Thomas?
Sure. I mean, what Bandwidth does is like selling a car with a seat belt and an airbag, all of the features that are required, and even ABS brakes, but someone can still get a speeding ticket because they're, using the device or the technology inappropriately. What we're going to talk about today is both nomadic and fixed, primarily nomadic, and how to use the underlying 911 products, not just bandwidth products, but there's other products on the market, and we're going to talk generally, and we'll talk also specifically about bandwidth, so that when you look at these regulations for fixed, you know what you need to do to be compliant. And when you look at nomadic, that's, laptop calling, soft phone calling, WebEx calling, that sort of thing, that you will also be able to achieve compliance with respect to the regulations. So we're gonna take you through those fixed nomadic compliances.
And from a Raboms Act perspective, tactically or more specifically, what does it mean, right? Or practically, what does Raboms Act mean? It means you have to deliver a dispatchable location. And I get that question a lot. From a regulatory perspective, Robin, what is a dispatchable location? And I like to say it practically means address line 1 and address line 2. Address line 1 being, the main front door address, address line 2 being more granular information. And so that's, as Thomas was iterating, that this, the world we live in today from a regulatory perspective is that for these non-fixed endpoints, think a soft phone client on a laptop that's roaming around, you now have to deliver that address line 1 plus an address line 2 for that endpoint when it makes a 911 phone call. So that's what we're going to dig into. So let's baseline here a little bit about location and what we mean by location in terms of the different stages of location that have been delivered to 911 over the years.
Right. So let's talk terminology. So we're going to use a lot of terminology on this call, or on this presentation. And so let's normalize, because there's a lot of terms bandied about. Okay. So we're talking about, folks know what basic 911 is, and I'll explain it in a moment. Basic 911, enhanced 911, next generation 911. And the question that we often get is, how do those pertain to voice over IP and 911 on a voice over IP call? And so within these standards bodies, we use the term I1 for basic, I2 for enhanced, and I3 for next gen. But what does that really mean? It means, and let's talk basic first off, what we mean by a basic 911 call. And you have to think back 30, 40 years when you go 911 calls got to the correct place, a public safety answering point or a police station, but it was ringing a hard phone. There was no name display. There was no callback number display. There was no location information, what now in Raboms Act we call dispatchable location. So basic is truly basic, and that's represented on the left-hand side of the screen. And you still hear people talk about basic, the red phone in the park ranger's office in, Yosemite Park. And so there are still a very small number of basic 911 call centers that are out there. I2, Voice over IP 911, sometimes called a VPC or a VoIP Position Center, is analogous to enhanced. What's enhanced? Well, on the screen, you see that the 911 call arrives. The caller's name or business name gets displayed. The callback number or the telephone number of the caller gets displayed, and their current address information. Now, what's important here is the address information contain a payload of a civic address, which you would think of as a street address. 123 Maple Street, Bug Tussle, Montana is one of my favorites in examples like this. But more importantly, for Raboms Act compliance, there's now a requirement for dispatchable location. What's dispatchable location? Okay, in Enhanced 911, dispatchable location is not the civic street address, but it is the location within that address if it's a multi-story building, floor 2, floor 3, or if there's multiple suites in floor 3, it's suite 301, suite 305, or for example, the room of a hotel room in a multi-story complex. So that's enhanced, and that's been the definition of enhanced, including the ability to deliver both street address and dispatchable location, that room level or floor level information. And then we go a little bit further and people talk about next gen 911. The reason we built this slide for this audience is that next generation 911 is as a British colleague once said, a grand kipper, a big red herring, okay, of non-pertinent dialogue in the industry vis-a-vis Raybom's Act compliance. And so in the standards, we have an I3 technology. You see it's very simple, basic I1, enhanced I2, next gen I3. But when you look at the display of what is an actual next generation 911 call delivery pertinent to the compliance requirements, okay, it's still name, number, address plus dispatchable location. There's no difference, okay. The difference, and this is upcoming in the slides, is that as a general thesis, the I2 technologies or the enhanced technologies are static. They're for a fixed endpoint that doesn't move around, and you provision name, number, address at a point in time, a week, a month, a year ahead of a 911 call. And at the time of the 911 call, that static information of the fixed non-moving device is used for 911. In I3, the devices can move around. And now we have what's the location of the moment, what floor is he on now, what room is he in now, which device is he using now, and what's the callback number for that device at this point in time. Because in a universal communications environment, everything can change. So with those definitions, Robin, I think we're ready to move on. Did I miss anything?
No, I think that's perfect. I think, some people might ask, well, so from a practical perspective, there's no difference between I2 and I3 in terms of what's delivered, and that's kind of true. Like you said, I3 really gets into it's not only what's delivered, but the main difference with I3 is how it's delivered, right? And some of the how things that
Correct.
are going to go on behind the scenes on how that call gets delivered to the PSAP and so on and so forth. Yeah. So no, that's perfect. Let's move on, and we've got to get to an architecture side, right? We got to get there and talk about. So great.
We have to have a big cloud picture.
We've got to have a big cloud picture on,
right.
on
so,
how all this comes together.
Absolutely. So this is the I2 diagram for enhanced 911. And if you've been in the industry, even for the last 20 years, the first publication of this type of diagram and standard occurred in like 2005. So it's been around a while. Okay. And this is, and I'm going to use this to illustrate 911 for a fixed device. All of the rest of the slides that you're going to see, we're going to be talking about nomadic devices and nomadic compliances. But as a stake in the ground for understanding of where we're at so that we know where we're going, this slide is pretty exemplary. We've done entire webinars on I2 call delivery and enhanced call delivery. But in simple terms, if you look at the slide, you've got your VoIP cloud or your PBX or your soft switch on the left-hand side of the screen. You have phones attached to it, okay? And you're provisioning within the LIS, that little database, the location information server, you're provisioning in there a telephone number and its location. Okay, so it could be also an extension and its location. The location would be, the main street address and that dispatchable location, what floor, what room. Okay, and so that left-hand side of the picture could be a Cisco UCM system, could be a ShoreTel, Mitel, Avaya, could be a Metaswitch or a NetSapiens if you're a larger carrier, and they all do it this way. And then that data from that list comes over to the list, location information server, on the bandwidth side, so that we get a copy of what telephone number, what call we might receive, right, from a telephone number, and what location statically to associate with that number, and potentially a caller name. Okay. You'll also see on this slide, and I'm only going to spend a minute on this, that we use the terms ELIN Earl at bubble 1 and bubble 3. What the heck is that? Well, for those, again, if you're on this call, you probably know all about ELIN Earls, but just for those who haven't, okay, if you have 50 extensions on the floor of a hotel, and say the third floor, and those extensions want to call 911. Well, it's an extension. It doesn't have a telephone number associated with it. And extensions, as you know, they don't cross the PST, and the extension data information doesn't. If you use an extension to phone your mobile phone, you don't see the extension pop up. You see some sort of a telephone number that was associated with that extension. And so that's a proxy number. just a telephone number that's used in the course of a 911 call, and they have a fancy name for it called an emergency location identification number, ELIN, ELIN. And so state of the art for fixed devices, static devices, is that a PBX or a soft switch would provision for its telephone numbers with a company like Bandwidth, the name and address of where the telephone number is as a static entity. It's not a non-moving phone. And if you have a set of extensions, they would also provision an ELIN, a proxy telephone number, and the floor of the building where those extensions are. Again, static. I'm oversimplifying this, okay? But the key is that all of the data, number, person or business, and address information remains static. And what I want you to watch as we move forward is look at the pattern of the clouds, okay? Look at the pattern on the screen. The call moves from left to right over to Bandwidth. We get this call. We go, oh, where's that from? Oh, it's the following telephone number. That happens to be an ELIN. Great. We now know the name, number, and address. We percolate the call down the screen to public safety through things called selective routers and alley databases. Doesn't matter. Down to the public safety answering point. That's the 911 call center. Okay. And that 911 call center, they want to display name, number, address. And through the virtue of that list and that alley database, this data that was pre and statically stored now gets displayed to public safety. Most of the folks on this call understand that. And the question is, what if that device goes home? The address is wrong. How do we update that address? How do we use an address of the moment when someone flips open their laptop in a Starbucks? How do we solve the nomadacy case? This diagram solves the static case, and now we have to move on to the next slide.
Yeah, exactly. So now we're gonna dig into several different examples of how people are solving this work from home solution. That's kind of the emerging phrase or term that we're hearing out in the marketplace is a couple years ago, everybody picked up their phones and went home. And they've got to solve them from I'm working from home now. I've got this phone device on my corporate network. What happens when I call 911? What needs to happen? Now, it's pretty clear, I think, from the regulations that we need to solve for this problem in this work from home environment. So that's exactly what's going on. So we're going to step through a couple slides each for some of these use cases, specific use cases. And the first one is relative to Ring Central and what's going on there. So, Thomas, you want to dig into that, and then the next slide after this is
Sure.
that architecture slide that we're going to come back and revisit.
So first, a disclaimer. We've got 3 examples, one from Ring Central, one from Zoom, if I recall correctly, one from Microsoft Teams. These are slides that we picked up off of the open internet. So this is all open information. This is an example of how a product deployed by those companies works. And we're picking out this as an example, not advocating any particular vendor here, but to use it to illustrate what folks have done to accomplish these compliances. Okay. And we've got one I2 example, which is the Ring Central example, and 2 I3 examples, okay? So we're going to grow in complexity. The problem statement that the Ring Central picture that you see here is trying to solve, and does solve, is, okay, I picked up my extension or my laptop that has an extension only, or maybe it has a telephone number, either case, and I moved to another floor in the building and my laptop connects to the LAN, and I'm now make some calls, and now I obviously need to make a 911 call. What do we do in order to track the movement of that phone? Or actually, the word track is a little bit sensitive. What do we do to instantaneously geolocate that phone in the case that they make a 911 call? You don't need to track them. You just need to, where is he now? And the way that we do this, or the way that Ring Central does this, and you'll see the little circle there, you see a Wi-Fi hotspot. You see a Wi-Fi MAC address, and there's going to be some IP data and some data that's sitting behind it. But what this solution does using an I2 technology is they go, okay, the laptops are going to be attaching to Wi-Fi access points. We're going to associate the street address and dispatchable location, the floor number or the lecture hall name at a university, or the cafeteria in a large enterprise, right? What floor, what room? We're going to associate that full dispatchable Ray Bombs Act compliant information with the Wi-Fi access point for all Wi-Fi access points in our enterprise, could be an entire university campus. And when the laptop moves from floor to floor, from building to building, across the campus, and now is on the 10th floor, and they flip it open and, it's the cafeteria and somebody's got an issue, and they make the 911 call, the address is associated with the Wi-Fi access point. The laptop soft application picks that up, and it uses the proxy number. Remember that ELIN technique, the I2 technique from the previous slide? It uses an ELIN associated with the Wi-Fi access point with that address, uses that ELIN, sends it off, and you can flip forward if you wish, Robin. See the architecture slide. And the call follows the same pattern as the previous legacy 30-year-old technique. And so here we have nomadacy within a campus environment, multiple buildings, multiple stories, using the Wi-Fi access network, not as data communications, but as the location datum of reference. And we use the I2 technique of ELIN Earl to make it work. Robin, am I missing any points on this? It's neat. It is a very elegant solution for in-building.
Yeah, absolutely. No, I think you nailed it, and we're right on line here. I think this is a great example of a basic solution that works. It is elegant, but it works well in these what I call on-net scenarios, right? Where the endpoints are exposed to a network, and you've got the PBX has visibility into that network infrastructure and can resolve a location like that, right? So we've got that. That's unfortunately that's only one of several use cases we have to solve for, right? And so that's where we'll transition to the next one, which is where we get into
exactly
a new technique. So go ahead. Yeah.
Exactly. So what happens if the guy's not on the campus, right? If he leaves the business environment or the university where there are no registered access points, he goes home or he goes to the Starbucks. Okay, here we have another vendor, in this case Zoom. And again, we have a little call out which goes, what's your work from home address? And so the I2 technique is name, number, address statically stored. In the Zoom case that we're seeing here is that now this I3 technique breaks apart the data that's going to be used to manage the 911 call. You have data for who the user is, their telephone number and name. And then you have plurality of locations where the person might be, okay? A home address, a Starbucks address, and they can input their address at this point in time on the screen in Zoom. And so the Zoom's going to do something intelligent with what we call our I3 solution called dynamic location routing. At the time of the 911 call, they are going to look at the call. They're going to go 911 call coming out of this Zoom instance, check the Wi-Fi environment. Am I on campus? Oh, if I am on campus, then the technique that we were just talking about with Ring Central, something very analogous, goes, okay, I'm on campus. I'm in this building. I'm on the second floor. I'm in the cafeteria. Let's get that data. It goes, no, I'm not on campus. I'm not in a known Wi-Fi environment. Hey, he filled in his work from home address. And that now, through a software technique called NAT address management, observes that, okay, he's working from home, and that work from home address, plurality of addresses are present, and we select the correct one at the time of the call and use it for that call only, not statically stored. This is an example of how a work from home scenario uses an I3 product, of which Bandwidth has a branded product name called Dynamic Location Routing. And so same picture, left to right, same set of clouds, right? But now we're just adding more intelligence into the SIP invites, and now we can get lots of jargon. Why don't you give us the jargon? Explain what a PITA flow is and a geolocation header. Let's dwell on that for just a moment, Robin.
Yeah, exactly. So when you get in these scenarios to support, these more diversified use cases where you've got some different location that's being determined, maybe individually, dynamically at the time of the call, right? It really requires the use of some different techniques to make this work. And so that's exactly where we're burrowing down into and getting to the gist of it is that you've got some different techniques that can be used. And a lot of times you'll hear us refer to those as location by reference or location by value. Whereas, what it does require, though, both of those techniques require the use of a special header in the SIP invite to make this call work through the system, right? And essentially what we've done is we've borrowed those next-gen 911 techniques to make all of this work. And so the originating service provider needs to provide this geolocation header. And that geolocation header is essentially going to specify the location we're going to use at the time of the call to route the call, right? And so as Thomas mentioned, now we get into some really nitty-gritty details, right? Location by reference, where you're just essentially assigning, hey, here's a reference. Here's the Wi-Fi access point attached to you. Do you have an address that's associated with that Wi-Fi access point? Use that address to route the call. Everything's good. We can also do location by value, which is, Thomas threw out that term PIDFlow, right? There's a standardized concept in the industry that where you can embed a PIDFLO, stands for Presence Information Data Presence Information Data Formatted Location Object, PIDFLO. We lovingly refer to it as PIDFlow, right? And so you hear all that talked. Well, when you hear somebody say, oh, does that call include PIDFlow? What it means is that it includes a location object embedded in that call that can be used to identify the presence or the location of that caller, of that call, of the device that's making that call, right? So again, PIDFlow is essentially correlates to an object. Now, that PIDFlow can be a location, an address, a civic address, 123 Main Street with a dispatchable location, floor 5, suite 530, right? It can include all of that. It can also be a latitude longitude pair, right? A coordinate pair that points to a point on that indicates a point on a map with a specific location, or maybe it includes both. I mean, there's a lot of variability here. There's a lot of cool flexibility that comes into play to solve these use cases in different ways. So when you've got a laptop with a soft phone client, we can apply parts of this to that scenario. Or if I've got a soft phone client on a mobile phone or a tablet, I've got soft phone clients on my iPad, right? A tablet computer. How can I take advantage of some of those capabilities that are inherent to those platforms to properly process a 911 call and provide it? Again, we want to make it as easy as possible on the user to be able to have access to 911. So that's some of those details you hear us talk about as we dig into this. And that's what we're seeing. That's what the bandwidth platform dynamic location routing is all about. It has this flexibility to look at this geolocation header and interpret if it's a location by value technique, if it's a location by reference technique, does it have a latitude, longitude, all those different things. We can use one of those techniques or a combination of those techniques to properly route the call and get it to the right PSAP as quick as possible.
So let's ground the conversation. Some of our audience is by now dizzy, PIDFlow, geolocation, I2, I3, and there's a lot there. If you're an engineer or a software developer, a SIP invite with the following headers and from fields to okay, it all makes sense. But let's ground it for a portion of our audience who are just trying to solve the problem of Ray-Bombs Act. So we talked about ELIN, URLs, and static. We've talked about being able to use I2 inside of a campus. We just talked about using I3 with these PIDFlows and geolocations to be able to specify an address of the moment. Okay. What we're talking about here for our audience is using these tools, these technologies, to define what your use case is. Is it to work from home? Is it a school system where all of the classrooms need to be identified, but none of them have phone numbers? Is it one user with 5 different phones, any of which can call 911? There's many sophisticated use cases. And what we're trying to provide you is the language of the tools necessary to build a safety compliant, a Ray-Bombs compliant product using portions of I2, using portions of I3, and the technologies that Robin just mentioned. And that great segue into Microsoft. Microsoft does some very cool stuff. So Microsoft Teams, you can well imagine that you can open up your Microsoft Teams instance, your Teams tenant instance on the laptop I'm talking about, or the laptop I have over here, or my desktop PC, or even my mobile phone. Plurality of devices with a single user instance, and clearly all 4 of the devices I just mentioned can be in 4 different places at once. And so what we have here for Microsoft is, I would assert, the most sophisticated LIS, LIS, Location Information Server, where many of the, almost all of the elements that we just talked about can now be provisioned. So in Microsoft, you can provision the MAC address of the Wi-Fi network that you're on, or the subnets of the environment that you're on, or the switch ports of a PBX or a router that you happen to be on. And all of those electronic datums can be augmented by a work from home address that's specific to the particular user. And they will figure out at the time of the call, where's the mobile now in both the work from home and the enterprise, and send that call using I3, the PITA flow that Robin was talking about, for where that user is with that device at that moment in time. Okay, so the plurality of the use cases now becomes manifest with products like Microsoft Teams. It's a great example. Robin, I think Microsoft is just released their work from home stuff, right? Do you want to talk about that?
Yeah, exactly. Yeah, so tying it back to the regulatory landscape and the timing of what's going on here is that there was that deadline in January 6th earlier this year, such that nomadic endpoints need to be able to provide that dispatchable location to public safety at the time of 911 call. And so to do that, to help their customers comply with that, right at the end of last year and into January, Microsoft released an enhancement to the solution that allows end users to provision their own address directly in their Teams client, right, so that they can augment and meet the regulatory landscape, or meet this regulatory requirements for a non-fixed device roaming off-net, working from home. I'm in a Starbucks, I'm in a hotel, wherever it is, right, and I can do that. And so what that looks like is here within the Teams client itself. You can see in the lower left-hand corner, there's an address. Now, what happens, what's interesting about this is whether I've got this is the Teams client on my iPad, or it's the Teams client on my laptop, or wherever it is, right? It's going to try and resolve a location using that list, that LIS that Thomas mentioned. If it can't, it's going to pop up a little notice to me and say, I don't have a valid location for you. I need an emergency location. Can you provision that? And that's exactly what it enables. So I can go in there and using that, the interface. There's a user experience built into the Teams client here that allows me to provision my own address, and then that's what's going to be used when I call 911, right? And so this is the technique. We see this as the emerging technique that's used not just by Microsoft Teams, but by a lot of, we kind of talked about it with Zoom as well. This is the emerging technique across a lot of different platforms that we're seeing used to enable end users to provision their own address so that you can be compliant with this non-fixed regulatory requirement or non-fixed endpoint to deliver a dispatchable location. Now, what's interesting about this, just to get into the weeds again for a second, is that the dispatchable location, in some instances, if I'm working from home and it's a single family, housing unit, maybe dispatchable, the address line 1 is all I need, right? But then what if I'm in an apartment, or I'm in a high rise condo complex or something like that? That's where indeed, right, you've got to have that dispatchable location, that address line 2 plus address line 1 to be compliant with the regulations here. And allowing the end user to do this seems to be the emerging, well, not seems to be, it is the emerging best practice for how to make this happen. Different vendors, just a note here, different vendors are approaching this slightly differently. You see a little bit of different flavors out there. Microsoft very easily lets you come in and do this. Other vendors are doing things like they won't let the phone register until you put in a valid address. I mean, there's different techniques that are being applied here. But again, that's just different people's interpretations of these regulations. And you'll hear Thomas, I say a lot, we're not lawyers. We can't give you legal advice as to exactly how to interpret these regulations. But just be aware there are some techniques to be used out there to adhere to these regulations. The bottom line is that you need some sort of next-gen dynamic location routing type platform to be able to solve these problems.
Yep. So you will observe that this diagram, now that's a Microsoft Teams diagram, is markedly similar to the other ones. Call flow is from left to right. You see the presence of the lists. You see the Microsoft list. You see the session border controller in the center of the screen called out because that's a very important provisioning and security item inside of the Microsoft environment. It's a little bit understated in the other cloud-to-cloud connections, but they're always there. In this case, it can be an on-prem or a cloud-managed type device, but the call still requires three things. And so here's your key takeaways, okay? How do you do a RABOMS Act compliant design and product? I would suggest that your takeaways are the following three things. Number one, distinctly and definitively define your use case. Who is the end user? How many devices does he have? Does he have a telephone number? Does he have an extension? Does he have just a URL, thomasginter@bandwidth.com, and that's my entire handle? Define your end user's experience. That's step one. Know it. Step two, figure out all of your provisioning pieces of information you need in order to exercise that use case. Okay. So we talked about, we need all of if it's going to be indoor and it's going to be multi-building, multi-floor, we need the Wi-Fi environment. We need a way to collect subnet addresses. Oh no, it's going to include work from home. We need a GUI or a map tile or some way to collect work from home address information, or potentially you do a Bing Maps pop and do some stuff on your end that goes, here's the address I'm going to validate. Step one, define your use case. Step two, figure out all of your sources of provisioning information and build them in. Step three, find an i3 toolkit like Bandwidth's dynamic location routing, where you can use a much more advanced SIP invite with the headers. We've mentioned PIDFlow. We've mentioned geolocation headers. There are additional headers. For example, a contact header can be used to manipulate the customer's name, can be able to manipulate the telephone number that's used on the display. There's ways of at call time defining every information element. And if we flipped all the way back to that slide that said I1, I2, I3 with the little picture that said, here's their name and here's their address, every information element that pops on that 911 call taker screen can be manipulated in real time at call time in the I1. Let me try that again. In the i3 product. Robin's laughing at me now. So that's the key point, okay? RABOMS Act is not hard, provided you've thought through what your user experience is, you know where your sources of data are for the provisioning experience, and you've got the appropriate toolkit, which is dynamic location routing, for example. Okay, there's other products out there. Of course, we're going to advocate ours. But the point is that this is not hard. We've given you three examples today of companies that have done it, each in a different way, each with a different technology. And we could literally spend another 5 hours going through many, many, many other companies who have used similar design experiences over the past, 2 years, 3 years to achieve their compliances on the dates. What they can do, you can do. If you're confused, give us a call. There's going to be contact information at the end. Robin?
Yeah, perfect. So we're starting to get some questions to come in, so we can move to those in just a minute. But let's wrap up before we move to questions and talk. Just kind of wrap up with the short list. What do you need to do, right? What do you need to do to become compliant with these latest regulations and get ready for all this stuff and make sure you're good to go. So first and foremost, as I said a little bit earlier, we're not attorneys. But go talk to an attorney, right? We highly recommend. Thomas and I are not attorneys. You should go talk to your attorney. And these regulations can be complex. It's up to interpretation. Go talk to an attorney and figure out. Just make sure you're in a good position so that you can document what you're doing and have a safe harbor for when the lawsuits that will come, and they will come. I know we're going to see lawsuits. Thomas, I've been like you mentioned at the very beginning. We've done this for many, many years. We know that some of those lawsuits are going to come. Get ready for them, and make sure you have a safe harbor, and you've documented what you're doing. Some of the other things here, include, test. I've used the phrase a lot historically that if you don't test it, it didn't work, right? And so testing is a good way, and make sure your vendor supports 933 testing, right? Use 933 testing is a great way to test a solution without impacting 911 calls directly, live 911 calls to the PSAP. You can do a lot of great testing with that. Okay. And Thomas, I'll let you cover the last two bullets here in a second. Those are the first two key things here from this short list are talk with an attorney, do lots of testing.
Right. So the last two are really important. So the first one, the first of the last two is Carey's Law, which says don't require your end users, and we talked about designing your use case, don't require them to dial anything other than 911. Not 8 to get an outside line, not click this box if you really want a 911 call. If they're on a native dialer, those are the 3 digits and the only 3 digits that should be required. And many old PBXs don't do that. You had to dial 9 to get an outside line or 8 to get an outside line. So that's rule number 1. That's Carey's Law. The last one, don't intercept, right? So key point is, a naive piece of thinking would be, I'm in a hotel, I've got 1,000 rooms. If someone dials 911, I'll let the front desk answer it. See if it's really important, and then I'll bridge the call over, call 911 on their behalf. Beep wrong. Don't do that. Don't intercept a 911 call. It needs to go to public safety directly. Campuses, universities might think that their security centers can intercept or participate in 911 calls, not unless they're a bona fide primary public safety answering point or secondary public safety answering point. And, you can't accidentally get in the middle of a 911 call without the approval of the officials, of the folks who are legislated to receive these calls. So don't intercept 911 calls unless you know what the words primary PSAP and secondary PSAP and whether you are one. So there you have it. Why don't we do some Q&A, Robin?
Yeah, absolutely. So let's jump in. First things first is we've got a couple questions about getting access to this afterwards and how can I share this online and so forth. So I believe this webinar is going to be posted and available, the recorded version of it later on, I think within 24 hours or something like that. So go back to the Fierce website. You'll be able to get access to it. No problem there. Just wanted to cover that. So let's get into some technical questions here, Thomas. I'm going to throw this one at you. Can the ELIN be any number, or does it need to be from the DID list for the customer?
Yes, sure. So the short answer is it needs to be from the DID list for the customer. Why? Okay. This is the number, the ELIN, this proxy telephone number that's going to display on the 911 call taker screen. So 911, what's your emergency? Oh, I'm sorry to hear that, Mr. Smith. You need and the call goes click. Uh-oh, we need to call Mr. Smith back. I dial that number. Okay. So that number needs to be, and the public safety answering point can dial that number. They could dial it from a mobile phone. It's not a 911 call calling back to a 911 caller. That's a normal telephone call. And so that DID needs to be in the PBX so that when the call comes into the PBX, it will ring the station with even whether or not it's an extension of the original caller, Mr. Smith. Okay. You can't use an arbitrary number in those traditional ELIN URL scenarios. You, just as a caveat, you can in an i3 next gen, it becomes much more flexible. But the question you asked, I think it's a fairly narrow answer. Yeah, it needs to be a DID in the list owned by that client such that calls are returned to the same box that initiated the 911 call.
Yeah, I'll just add a little color to that from the perspective that Thomas is absolutely right. Really, this ELIN number, it should be a reserved number, but it has to be associated with the originating. What I'm going to borrow the FCC term here, the MLTS network or the MLTS system, that multi-line telephone system, the PBX, right? It needs to be able to dial back to that. Now, how that PBX uses that ELIN can vary a little bit from PBX to PBX, but the general rule of thumb here, the heuristic, is that indeed it does have to be, from that. It's got to be a DID number that's associated with that PBX. Absolutely. Okay. Next question we want to throw out there is that Thomas and Robin, you guys have been doing these webinars on this subject for what seems like several years now. In the last 9 to 12 months, what's the most significant update in the situation that you see?
So that's a great question. So the nomadic deadline passed, several months back in January 6th. And so the nature of the conversations we've had, up until that point were, how do we get compliant? What do we have to do? Do we have to buy new stuff? Do we have to build new stuff? Do we have to provision new stuff? How do we get this done? And then after the January 6th, we get some incoming calls, and it's, how badly non-compliant are we? And we're not lawyers. We can't tell you. What we can do is what we just talked about a couple of slides ago. Tell us what your use case is, and we'll and what provisioning information you have, and we'll tell you how to get that call, best practices style, down to public safety. Your use case, how you actually give the user their 911 experience, that's your judgment, and that's the thing that you want to have the attorney look at, right? You build a use case that says, he has to dial 8 to get an outside line and then dial 9. Well, that's clearly, I don't even need to be a lawyer. Clearly that, I just said that, don't do that, right? That's obvious inside of Kerry's law. But the nuances are things that you want to completely identify, discuss with your attorneys, and then talk with us on how to build it out the way that you want the end user to experience this. We're happy to help.
Perfect. Getting some more questions coming in. Keep bringing them. We appreciate it. One question here, which I think will be a quick, easy one to cover, is NextGen 911 the same as NENA i3?
Why don't you take that one? I'm interested in your opinion, Robin.
Yeah. Well, that's exactly it. Let me answer it from this perspective, in that you can ask Thomas and I, what is NextGen 911? Is it the same as NENA i3? And you can ask 5 of our expert colleagues out there in the industry from different companies, different aspects, and you're going to get 10 different answers, right? The reality of the situation here. So NextGen 911, right? The concept behind it, I'll put it this way: NextGen 911 is the concept of really the evolution of E911 into the next gen environment, and what it's all about. It's all about providing new capabilities in the 911 ecosystem and moving away from legacy technologies, right? I think NextGen 911 is all about moving away from legacy technologies to specifically IP-based technologies. So a very, very super simple way to put it is NextGen is all about getting rid of legacy selective routers and implementing new IP-based networks. Now, when you look at a 911 call, right, it goes through several different aspects of originating service providers through a 911 network to a PSAP and so on and so forth. And NextGen is all about how do we do that without old legacy technology. Now, NENA i3 is the industry attempt to establish a standard for how NextGen should work. So that's really, one way to look at it is that, NENA i3 is NextGen 911, but a more liberal way to look at it is that it is the standard that should be applied to accomplish next gen 911. Cool.
That's
Okay.
exactly right. So the standard, just so that folks have a frame of reference for it. Oh, go ahead.
Go ahead, please.
What's our next question? I was just going to say that the standard itself,
right,
last time I looked at it, is 1,200 pages. Slight delay. Keep going.
Yes. Yeah, exactly. It is long, and there's a lot to it. And then there's also there's not only just the I3 standard, but there's ancillary standards as well that are being developed to help move. Once we're starting to see these IP networks get in place, we can. The promise of next gen is to include video and text to 911 and all kinds of new modals and additional data. That's where we're going with all that. Let's move on to the next question. When you say, and we're going to bounce around here a little bit, but when you say eliminate any prefix to call 911, are you saying to allow calls to 911 but block calls to 9 plus 911? And so let me talk about this for a second, then Thomas, you can add some color. But no, so the idea, what Kerry's law was all about, the intention as I see it, right, is that what you want to be able to do is it's really about the end user experience. Somebody should be able to pick up a phone and just dial 3 digits, 911, right? And so it's based on the fact, Kerry's law is based on the fact that there was a lady that was being assaulted in a hotel room. Her daughter picked up the phone in this hotel room and tried to call 911, and that's all she dialed. All this daughter dialed was the 3 digits 911. She didn't realize you had to dial a 9 to get an outline access, to get access to an outside line to be able to call 911, right? So she didn't realize you had to dial 9 plus 911. So how does that manifest in the environments today? What we're seeing is that what the law is saying is that you need to be able to allow that to happen. You need to be able to allow somebody to pick up a phone, dial just 911. Now, what ends up happening is people accommodate, these PBXs are able to accommodate if somebody forgets, I'm going to try and dial 9 plus 911. Great, I'm still going to get through to 911. I dial 8 plus 911. I still get through to 911. I just dial 911. I still get to go through 911. We want all calls to get access to 911. You never want to block any call going to 911. And the law doesn't allow for blocking of calls to 911.
Right.
Cool.
Yeah, still not a lawyer.
All right.
Keep going.
Still not a lawyer. Perfect. Let's see. We answered that one. Let me get organized here. All right. Here's a good one. For a roaming caller on campus Wi-Fi, what is the requirements of the Wi-Fi design to ensure correct floor or building? Say, for example, a user connects to a Wi-Fi access point from outdoors or a floor above or below the actual physical location of the caller.
Sure. Okay, I see that my video's jumping, so jump in here, Robin, if my system cuts out. That's a lawyer question.
Cool.
Okay, so you can use a Wi-Fi access point for location as the location datum. The question is essentially, is it accurate enough? What if it's off by a floor? What if it's off by 100 feet? Okay, and that's a lawyer question. Right? We can't answer that for you. All we can do is tell you the best practices of using the best location information that you have at that moment in time. Let me give you an example. Okay. If you were building that solution as a best practice, I would ask you, okay, if you're wandering around outside, why are you not augmenting your Wi-Fi with a GPS set of coordinates and doing a point and polygon calculation? All right. And so it now becomes an engineering design question. And once you figure that out, right, then you can go back to your lawyer and go, this is how I'm going to design it. He's going to ask a whole bunch of questions. And you're going to go, may I proceed? You never ask the lawyer, is it good enough? There's never good enough. But you go, this is my design. Do you object? And then proceed. So there's lots of ways to do location determination. If your attorney, suppose that you're in some kind of a facility that had such stringent security requirements, maybe I can't even think of one, but maybe they go, location has to be locked down to 1 meter accuracy, 3D all the time. And they go, that's the physical requirement. Well, you go, okay, I guess we have to put RFID tags in the floor on 1 meter squares. That's an engineering solution to that kind of requirement. Is the requirement required under Raybaum's Act? Do you have to have 1 meter accuracy? I'm not a lawyer, but Raybaum's Act doesn't provide that type of stipulation that I'm aware of. And it's a reasonable lawyer question. And you can have an engineering solution for it. I would say that it's significantly overkill. Robin, what do you think?
Yeah, I agree. I think it comes down to, again, Raybaum's Act and those regulations say what you have to do. They don't say how you have to do it, right? And that's a good way to approach regulations, in my opinion, right? Again, not a lawyer, but I think that's a good way to approach them, is to say, all right, we need to deliver this dispatchable location. Now, whether or not a location associated with a Wi-Fi access point that may bleed from one floor to the other, or may bleed, from one conference room to the next conference room, is that good enough? Ask your lawyer. I mean, that's really what it comes down to. That's the bottom line. Okay. I think we've got time for about one more question, and then we'll turn it back to Liz and so forth here. But I think this is an interesting question, and I can jump in on it first, and then give you a chance to answer as well, Thomas. But does stir shaken play any role in NENA I3? Right. The question, does stir shaken, and I'll expand on the question, say, does stir shaken play any role in 911 to begin with, right? And how that's going to go. So right, backing up half a step, right? Stir shaken, for those of you who may or may not be aware of stir shaken, right? It's all about attesting calls, certifying calls, and security for calls as they traverse through networks from one network to the next, right? So I would generally say the concept of stir shaking, the concept of securing calls, has been around in 911 before stir shaking was ever thought up, right? The concept of and that's what's been going on in 911 for a long time, is how do you secure these calls, and how do you make sure that calls coming into a 911 call center are actual 911 calls, right? And there's been a lot of work done over the years to make that happen. Now, my understanding is that NENA and more importantly, Addis, I think, is contemplating some of these stir shaking concepts into some of the 911 standards moving forward. But it's not going to be a one-to-one match. How you think of stir shaken within what's going on within the voice world today is not going to apply perfectly into the 911 space. But there are concepts being considered in that realm. There are absolutely no requirements for implementing anything like stir shaken in the 911 space today. Are we going to see something like that? Maybe. They're starting to contemplate that. But I would venture to guess, and now Thomas is going to cringe and say, Robin, don't guess, but I'm going to venture to guess that what we end up with is not going to look a lot like what stir shaking looks like today.
Yeah, I would agree with everything you just said. So, and I would broaden it just a little bit. You could ask, will stir shaken apply to all of the call legs, all of the legs in a 911 call? Should encryption apply to all of the legs in a 911 call, or any of another set of technologies that has not traditionally been applied to 911? And the question they asked was, will it have an impact? We can't predict the future. Does it have utility? Highly debatable, right? Is it required by law? Not at the present. There you have it.
Perfect.
Still not a lawyer.
So with that, I see we're almost at the top of the hour. Yeah. So with that, we're at the top of the hour. I'm going to turn it back and thank you so much, everyone, for your time and your questions. I'm sorry we didn't get a chance to get to every single question, but we really appreciate the time.